Well, welcome. So excited that you all are here. We have a really good attendance here, so we should have some really good questions going through the webinar. But today we're going to be talking about signs to know, is your custom software now legacy? How do we know, and what do we do about it? And we're talking about those signs to help you know this and to help you figure it out. It may be obvious. Some of you may be saying, "Oh, there's no doubt in my mind," but there's also some good and easy signs that you can check, even if the technologies being used are more fairly modern. So let's get started. All right. So ClearMeasure is a US-based software engineering firm. We focus on modernizing custom software built with Microsoft development technologies. We're a Microsoft Gold Partner. My name is Jeffrey Palermo, and I happen to be a recipient of the Microsoft MVP Award for the last 12 years running, and been in custom software on the Microsoft platform since 1997, so a little over 20 years. And we focus on custom software systems, any version of Visual Studio going back the last 3 decades, and including Visual Basic 6, even Visual InterDev and Active Server Page IDEs, and really going back well into the 90s. And we focus on 2 elements: things that are holding back the actual software from taking advantage of modern techniques, modern environments. Cloud is all the rage, newer techniques and methods, but also modernizing the capabilities of your team so that you can reverse any things that have happened that have caused your system to fall behind the times. And so we'd like to help you modernize your capability to modernize your own software and enable your developers. So our agenda, we have these 6 categories of discussion elements. We're going to be talking about the importance of custom software, the impact, the impacts of risks that do exist across the software industry, how to identify symptoms, characteristics of modern symptoms, so we can juxtapose those against the system that you may have, and then what to do next about it. So we'll dive into the importance of custom software. Your employees across departments rely on custom software applications that you have built at some point, whether they be VB6 or Fox Pro or Active Server Pages, older versions of .NET. These custom applications help your people get their work done. And when your hardworking people experience errors or slow performance or downtime, they can't do their work. And business interruptions, they are costly. Further, when these problems occur, the time that it takes to resolve those issues with the system, it's lost productivity, lost revenue, increased costs, and so it's a big deal. And stability problems are also a big issue, and the persisting of these stability problems are a good sign that the custom software that is a big asset line on your balance sheet, it may be turning into a risky liability. So every one of you knows how important your custom software system is to your business. It's intertwined, interlaced with every bit of the day-to-day functioning of the business, and very, very important. So a little bit of context around the type of systems and why you might have reached for custom software and built your own custom software or had somebody build it for you at the time is there's no available commercial off-the-shelf packages for it. If you need a CRM, you're not going to make that custom. If you need an address book, or if you need if any number of software packages like tracking a shipping or loading deck, or tracking the timekeeping for shift work. There's plenty of commercial off-the-shelf packages, and even today you wouldn't go after that. But if what you do is unique, you compete on it in the industry, that's not going to be in a commercial off-the-shelf package. Any number of these ERPs could say, oh, we'll customize your thing into our package, but then you're still doing custom development. You're just custom developing that into this particular product, and you're using a development platform with a much smaller labor force than, say, using Microsoft.NET, which is half the developers in the world. So our focus today, the context, is on systems built with Microsoft development technologies and running on some flavor of Windows Server, or even in Windows Azure, and databases on SQL Server. So that's our context. Now, let's dive into risks across the industry. There are a number of them. Let's just dive into them. First of all, security breaches. You've seen it in the news, and you don't want to be the next one. However, you may have a legacy system if you really don't have any way of knowing, really knowing for sure that your system isn't going to be breached. And you know, even the most simple of online systems are constantly being attacked. If you do the analysis of your logs, you will see IP addresses from other countries constantly trying to find ways to get into your system that has a surface area on the internet, whether it be just a web service API or a website. Whatever you have exposed to the internet is constantly being attacked. That is a fact. And if you haven't looked at your logs lately, I'd advise you to go look at them, because there are people all the time trying to get into your systems. They have scanners across the internet, and if they find an endpoint, then they're constantly trying to go into it. And that happens with our clients, and we analyze it, and we take preventative measures to block those people with firewalls, close any security holes, and any known vulnerabilities with libraries. For instance, here's a one that a lot of people have used. There's an HTML editor called FCK Editor that allows you to put rich HTML onto a form. But there's a known vulnerability, but that thing was widely adopted. And if you don't know about it, and if it's in place, then it has a vulnerability that allows files on the file system of the server to be modified. And so security breaches are a big risk. Technology obsolescence is also a risk. You might have Windows Server 2003, it's obsolete. And you might still have code on active server pages. When Microsoft doesn't provide support after 10 years, 20 years in some instances, then the technology obsolescence starts to become a risk. Poor performance is also a risk if at certain times of the day the software is just slow, and your users will tell you about this. This seems to be an obvious trend, but it could be unpredictable. Another is high maintenance costs, which we'll go into quite a bit more in this webinar. But stable and modern software systems have low maintenance costs, not high maintenance costs. We'll talk about what that is. And then chronically missed development deadlines. If you have a development team working on this system and they're asked to estimate something, and then they do, and then they chronically miss the deadlines, that there's more things going on in that system. We'll talk about that as well. And then staff attrition. If people assigned to the particular system quit, and you have a hard time rehiring because of market forces, that's another risk, because if you can't tap into a labor pool that's appropriate for the system, then those costs go up quite a bit. Okay, so let's talk about the impact of those risks. First is strategic. Let's dive into that a little bit. This software system that you have, it costs a lot of money, and probably capital was raised in order to develop this originally whenever it was developed. And so it is considered to be an asset, and it's definitely an operational asset. And the impact of these risks is that asset could slide into becoming a liability. And when you have a liability, the liability has constant expense ramifications every single month. So, pardon me. So for a sample system that has 100,000 lines of code, well, roughly that translates into $500,000 to $1.5 million in order to develop that system. Capers-Jones puts out a lot of accumulation of research, and there's some rules of thumb and some averages across thousands of projects that have been researched in the industry over the last couple of decades. And that's sort of the range. And once a system or a major release is put out, the average is about 15% of the cost of building it as maintenance cost for each year for the first couple of years as it stabilizes. And so for this type of system, you would expect to have $75,000 to $225,000 in maintenance costs for the first couple of years after it was put out or after a major overhaul is put out until that stabilizes again. And then once it does stabilize, then maintenance costs goes down and you find a much smaller figure in order to support and maintain this system because it stabilized, all the problems have been found and whatnot. So here's an issue in here that a lot of our clients find themselves in. If your custom software requires entire developers in order to keep the software going, then your maintenance costs may be sky high. Think of the salary and the benefits and the equipment and the licensing just to have one developer. If that developer is assigned to that system and most of what that person is doing is maintenance as opposed to strategic new capabilities for the system, then you have to factor in all that costs. But if this developer is completely dedicated to supporting the software, then they have stopped being software developers, but you may still be paying that software developer's salary for a support technician. And developers don't like to be support technicians, so you might have attrition risk if they need to go to another company in order to have software development opportunities. This also comes at the cost of future software development, impacting future business initiatives for the next quarter, for the next year, and chances are that this ongoing costs were not in the projections when the original capital was allocated for this system to be developed. But now that the system is here, this ongoing expense persists and it grows in many cases. Also, there's another impact. It's about complete system failures, business continuity, and disaster recovery. If you have a system in this state, you probably don't have a practiced and proven way to reprovision, and reinstall the system if a complete failure occurs. If you have a security breach, you don't just keep those same servers running. You have to rebuild those environments and reinstall everything because you don't know what happened, and you can't guarantee that you're clean again, even if you can recover. And then if your data center has a fault or a failure, or your VMware Hyper-V or your data center cabinet has a failure and you need to rebuild the environments either in the same data center or in a completely other data center, if you don't know how to set your entire system up from scratch, then your business could be down for an extended period of time, and that could be catastrophic for a lot of firms. So that's the impact. So let's talk about how to identify those symptoms. All right, what to look for. So these are very, very simple and basic and fundamental things that any executive or manager or even peer on development team could ask for in order to get a sense of whether this is a well-kept system that has kept up with the times, and we could call it modern, or whether the system has not been well kept and has the term legacy applied to it. And so let's go through one at a time. First of all is about record keeping. Not a whole lot of records, just some basics, some absolute basics. And really, it's diagrams. I mean, we don't need a whole lot of documentation in order to suss this out, but just if you were to ask the team, if there is one for the system, or whoever is in charge of it, ask for the architecture diagram for the software. How many components are there? What components are dependent on other components? And just the major technologies that each one is running. Very basic, because any modern system that an active team is developing, not only they're going to know that off the top of their head, but they're going to have diagrams that represent that because those are conventions. And so software architecture diagram is the first one. The next diagram is the server topology. How many servers do we have, and what is installed on each? You may have a very small system, but you may have a system that has several IIS websites with various technologies. You may have several command line exe programs that run from scheduled tasks. It may have several Windows services that are perpetually running. It may have some processes that run from the SQL Server agent on a schedule. It may have one SQL Server database with some number of tables, or it may have 6 different databases that are used by varying components. But the question is, what's running on what server infrastructure? And that's really all. That's really all. And if you can't find these, then that's a clear sign. If they just flat out don't exist, then that means that knowledge never was captured in the organization. It's walked out the door, and whoever is maintaining the system has to go and relearn that from scratch every time. And you're probably beholden to 1 or 2 people who just happen to have that knowledge in their head. Next is inspecting the basics about the environment. And so you ask the team, hey, can you set up a new demo environment for me? Yeah, just go ahead and set up everything on a demo environment. It doesn't have to be high scale. Just go ahead and set that up. Or ask them to set up a new developer workstation with all of the components functioning. And for modern software, that's no big deal whatsoever. It's with modern methods, it's no big deal. But for systems that have fallen out of repair, that haven't been kept up, and have started to become legacy status, that is a big deal, because so much knowledge is required to set up a demo environment if automation has not been employed, and then it's knowledge that's in someone's head, and it could take days in order to do that. So that's another thing you can check. Next is reviewing the logs and any metrics or telemetry that's coming from the system in production, but also coming from the system in pre-production environments. So there's a couple of things that have happened over the industry, the progression. One of the new methods is log centralization and telemetry aggregation, so that someone without production access can look at to see what the system is doing. That's a modern method, and it can be easily adapted to existing systems. But if a system has not been properly cared for and properly kept up with the times, and if that system has been allowed to fall behind, then the older paradigm has been that every component might have its own log file locally on the production server. The telemetry has not been instituted, and it's likely that in order to get visibility into what this system is doing, what the various components of the system are doing, you have to have someone with production credentials to log onto production servers or the production SQL Server databases and run some queries in order to just know what the system is doing and whatnot. So you want to ask some simple question. Hey, over the past month, what users have experienced errors? And if that answer can be produced very quickly, that's a good sign. If that answer has to be go into the production database and let me look at some queries, or let me go through some log files of various components in order to guess, or, well, I can tell you how many users complained, but I can't tell how many users actually received an error, then we have some signs there. And then what percentage of the production incidents have been escalated past level 1? The normal levels for supporting a system in production are 1, 2, and 3. Level 1 is quick response, triage, categorization of the issue, and using the knowledge base in order to come to a possible resolution without having to escalate. If the issue has happened before, there's a knowledge base article about it, and we can get past it. Whether it's a technical alarm that went off, a technical issue like a hard drive getting a little bit too big on a server, or if a user reports a problem and one of the components can be quickly restarted and then the problem goes away. That's resolution with level 1. Escalation to level 2 is when something has to be diagnosed on the infrastructure, on a server, and so you need more of the server administration or systems engineer skill set in order to resolve that. And level 3 is the software engineers who, if it's that kind of problem, might have to actually fix a bug in some code or uh, change some data that only they know in order to resolve the issue. But if it gets past level 1 and over 80% of the issues are going straight to a developer, then that's another sign. And another really obvious sign that you probably don't even have to inspect is difficulty making changes. If the developers who are in charge of making changes can't do anything in a week and have trouble estimating, and they don't want to make some changes, even though the business would love to make those changes, that's another sign. And perhaps more and more common in 2018, teams want to use an agile method, but they can't because the system doesn't allow the frequent production of a new release candidate and the frequent deployments and frequent testing, which all agile methods shrink units of work to a small batch size. And that means doing things quickly and producing multiple release candidates and multiple builds, multiple deployments. And a system that has not been kept in good repair has difficulty with that. But if you aren't sure, if your system has fallen behind and is jeopardy of taking on that liability of being a legacy system, just ask us for a quick assessment and we can get through that. Okay. And as we move through here, there's a Q&A window in the webinar. If anyone has any questions, feel free to type those in, and we'll have a time for questions at the end as well. But type those into the Q&A window, and at breakpoints, then I can ask those or answer those. Okay, so let's talk about characteristics of a modern system. A lot of people have heard that in law enforcement, in the monetary system, the training is all around studying what a real dollar bill is in order to find counterfeits. Instead of studying the types of counterfeits, they really study and teach the characteristics of a genuine dollar bill, and by studying what it should be, they can easily pick out counterfeit. So let's talk about characteristics of a modern system, so that armed with these, you can look at your existing software systems and say, wait a minute, that doesn't look like a modern system, or this area of it isn't using an available modern technique. What's going on here? All right, let's dive through them. So here are some modern signs. And this is all about the fitness for the purpose the software was intended. And the code of the system can be code from the 90s. That's no problem. We're not talking about the latest and greatest frameworks or programming language features. For instance, we have a client who built some early active server page code and had it running in the 90s on NT4 server with an early version of IIS, and it had pound include files for the top of the page, the middle of the page, the bottom of the page. And right now, that code is running in Azure. It's running in a fully supported environment in Azure, and that code has been ported and upgraded from a runtime perspective since the 90s, but it has not been rewritten. There are still pound include files. So the code was written a long time ago, and for this client and the volume and the size of the system, it doesn't make sense to rewrite code that is functioning well if it can run and be operated and be supported in a modern fashion. So this is not about losing out on old investment. This is about preserving previous investment and making sure that previous investment continues to stay with the modern times and is ready to serve the business for the next decade. And by the way, that system can be changed on a dime. So you don't have to be using the latest frameworks that just came out in this past year in order to use all the modern methods and techniques. That's the good news. Okay, so some modern science. The first is it can be built easily, producing new version labeled release candidates. And if it's hard to build, if it's hard to make changes and go through a build process and produce a new releasable artifact, then that that's a sign that it's fallen behind, because all modern systems can be built easily. Continuous integration is a commodity method in today's industry. I mean, for uh, most Visual Studio based software applications, you can get the basics of continuous integration working in half of a day and sometimes less, and then you just build on from there. The second sign of a modern application is that it can be deployed to a new test environment without having to get a production database restore, without production data, because you don't want production data in non-production environments. And new test environment, that's key. Brand new environment from scratch, and it can be deployed. Another sign of a modern system is that it can be promoted to existing environments, promoted from one environment to the next. If you have a first line dev test environment that runs automated acceptance tests or automated full system tests or security penetration tests, and it passes, then you know that that particular release candidate could possibly move on to a manual test environment where humans can check out that version of the software. The next one is that key transactions of the software can be tested quickly and with low setup time. That's key, low setup time. For instance, if we're in a manual test environment and your system has 20 different functions where people are just using those functions all day and night to keep your business running. Of course, the system does a lot of other things and a lot of combinations of other things, but to do a full regression test pass would take a long time from a manual basis. But we should be able to quickly test the most common and the most critical key transactions to make sure that they didn't accidentally slow down, one doesn't accidentally have a big problem, because these things, probably 80% of the transactions that run through the system would run through 20% of the features. The 80-20 rule always tends to apply. And then the next one is logs and telemetry can be analyzed by a technician who does not have production environment access. This is important. Modern systems have logs centralized from the various running components on the various servers or services, if you're using Azure PaaS, for instance, and pulled out into a monitoring system that is not part of the production environment, so that we can observe and monitor what the system is doing without actually having to have production credentials to the very servers that it's running on or the databases that store very sensitive data. That's another modern technique. And if the key transactions are kicking off, hey, this key transaction happened, then you can use data analytics capabilities and tools like Power BI or even Microsoft Excel to do quick counts and say, hey, today versus every other day this month, how many instances of key transaction 1 did we do per day, and plot it on a line graph. Well, modern systems can do that because the logs are centralized. And it's not hard to do either. And the last modern sign is that level 1 and level 2 support staff handle 80% of the production incidents rather than having to escalate to the developers. Or the system is so stable and the incident count is so low that level 1 and 2 are accomplished even without dedicated support staff. And possibly just only on-call staff or shared staff. There's modern systems, there are a lot of methods that make the systems more and more stable. Okay, so now that we've talked about risks, signs of a modern system, here's what to do next. Your system is at the current state that it is. It's a really important software system. You're not going to throw it away, even if there's things about it you don't like about it, and even if some of the developers have said, hey, when are we going to be able to rewrite X, Y, or Z? If every system except for the smallest of small, the price tag is too big, it doesn't make a good return on investment decision for the business to throw that away and start over. It makes much more sense to preserve that investment and resolve and remediate the issues that are holding it back and prepare it for the next decade. So here's what to do next. The highest value remediations of a legacy system. And you know what? There's one. There's one that's universal. And I apologize, it does include an industry buzzword, but I'm not talking about buzzwords. I'm talking about methods. I'm not talking about tools or products. There is no magical tool that you can buy that is going to fix it. This is all about methods and techniques and how you do it and how you approach it. So the universal activity that enables everything else to be resolved is to implement a very, very basic DevOps pipeline. And I'm going to talk about what that is. You may, in the analogy of a house, you may have a bathroom that is so far gone that you don't even want to walk into it. But you don't need to bulldoze the house, even though you may need to completely gut that bathroom and rebuild the bathroom. You don't need to demolish the house. Same thing in your software. You may have a section of your software where you say, man, we need to redo this section of the software. And that could be your reality. But doing that invasive changes into a piece of your software without any foundation of an end-to-end development environment is very, very risky. And your own developers may know that because maybe they've been hesitating, or maybe that's why that hasn't been done for so many years. And so this recommendation here that we're about to go into sets the foundation for your development environment and enables every single other modernization activity that you would do. Any other change you want to do, if you know that you want to shift the architecture from A to B, or you want to take a certain component or subsystem and you want to make some fundamental changes, doing it without a safety net is very, very dangerous. And so whether you want to call it your foundation, your development environment, your end-to-end development process, or a safety net, it's all the same thing. It's putting in place fundamental modern methods that are going to keep you safe as you make whatever change you choose to make to your system. So let's go into it. Okay, so this is a basic DevOps pipeline. Again, we're on Microsoft platform, so this is all Microsoft, and it's not that in depth to get it set up. Now, to make it complete and sophisticated, this will be a living and breathing thing that you'll want to enhance over time as you get more sophisticated. But to set up the basics is not that much effort for all but the most massive systems, okay? Because if you have some number of IIS websites, if you have some number of executables that are scheduled tasks, you have some number of Windows services, you have some number of SQL Server databases, if you have some number of web services that run in IIS or run command line, even if you have some number of iOS or Android apps that are in the App Store that then connect to a web service, those topologies are known quantities, and there's only a finite number of types of application runtimes, so you may have 3 IIS websites. They may be small, or they may have 3,000 functions, 3,000 pages each. From a development environment standpoint and from a DevOps standpoint, it's an IIS website. So that's the good news. So let's go through this in briefing. And by the way, if anybody wants this for a in-office poster, we have that available. Just reach out to us. Plotter size, architecture D paper for a poster to hang on the wall. Glad to help you out with that. Just reach out. Okay, so the first step, and again, you have an existing system with all manual processes. First step, you need to have a private build. All the developers need to agree on some private build script to run where it does a compile, it links everything together, and does some number of automated tests. If you don't have some, just create a few. And we run that before making changes and pushing changes to source control. Version control needs to be one application per repository, one deployable unit per repository. In some cases, a version control repository may have dozens of different software code bases in the same repository and using it more like a file share. That just needs to be shifted around a little bit because you need one deployable system per repository. Then you need your continuous integration build. With Visual Studio Team Services, which is the Microsoft Platform Continuous Integration Server, it's, you click a few buttons to get the basic scenario running, to watch your source code repository, run your private build script, which will basically include compiling and running whatever test suites that you have, and then packaging your application components into NuGet packages as releasable release candidates. Then we push those release candidate packages up to package management, which is also in VSTS, and then we start deploying to environments. There are 3 unique types of environments in a DevOps pipeline. There's really 3. The first type that you all know is your production environment. The second type, that again you all know, is an environment for manual testing where humans go in and do something in order to validate something. The third type of environment is a no humans allowed automated validation and testing environment where the software is automatically deployed there and then test suites are automatically run. You could have a functional test suite. You could have integration test suites. You could have penetration and security testing suites. You could have accessibility testing suites. You could have any number of static analysis tools, or just the chaos tools that click every link in a website, or any automated test you could imagine with Selenium or Fitness, but it's a no humans allowed environment because a release candidate gets deployed, those get tested, and then it gets thrown away. Next release candidate comes, gets deployed, gets tested. So if a human were to try to go onto it, it would just be a waste of time because the system would be pulled out from under them. So those are the 3 environments. Most people do have 2 of the manual test environments. So in this picture, we show the first line test automation environment. Then we show a QA, which would be manual. Then we show a staging environment, which would be a manual validation, and then production. One of the things that you want to do as a basic part of your pipeline is to put in a system self-check API. And you put that in every environment. After an automated deployment, which is really just scripting out the steps that you probably have in a Word document, that, step 1, do this, do this, do this, do this. Well, let's write some PowerShell. Let's write some command line scripts, or let's use the tooling just to setting up IIS and setting up Windows services and setting up SQL Server is pretty much out of the box with the available tools in the marketplace. But a system self-check after you deploy calls out to the application itself, a public sort of an endpoint on the running application, and if it returns 200 OK, the system's up and running. Then your developers just write one new page or API or MVC controller, whatever you want to do, ASPX file, doesn't even matter, and you just write simple lines of code. If you have 2 SQL Server databases that need to be online, well, write a simple select to each one, and those will fail if the database is not online or if the connection string did not get set appropriately. And so whatever components or dependencies you have, write one line of code to just tickle that dependency. And that way, after we deploy, when we run that self-check endpoint, it tickles all the dependencies, and if all of them come back, well, we know that that's a good deploy and that they've all come back and they're all connected properly together. And so putting in place a basic DevOps pipeline is so important, and it is the most impactful thing that you can do. And I am not trying to stress a buzzword, but if you've heard of continuous integration or continuous delivery, those are methods that are in here, and regardless of what the buzzwords don't matter. The important part is enabling your team to actually make changes to the system, because you have things that you want to do to the system to make it better, to upgrade it, to add new capabilities, but you're held back. Something is holding you back. This is the enabler. This is going to enable anything that you want to do, regardless of what you call it, because I don't care about industry jargon. Regardless of what you call it, this capability to have a very fast cycle time between changing some source code and having it run through multiple validation processes, having it running on actual environments, and then checking it out, making sure everything's okay, and then making a decision, a business decision that says, yes, we're going to go to production, and you press an approve button, and now the same automated process just carries it onto production, instead of having long and stressful and destabilizing production deployment maintenance windows. It doesn't have to be that way. The methods of the industry have come so far. Even for existing systems that have lots of issues, this is an enabler. And the last point is production monitoring. Whether you're at Rackspace or your own data center or Windows servers anywhere, Microsoft's new monitoring solution is called App Insights and Operations Management Suite. And it can monitor systems running anywhere in the world, and it pulls all the telemetry together, all the logs, whether even your IIS logs, and even if you're doing a trace.write line or log4net or inlog, regardless of what you're logging, you pull everything together, and then from one place, you can use Excel, or you can connect Power BI, and you can start to aggregate all of the logs from the various components of your application and get a true sense for what your application is doing, your entire system is doing, all the components, without having to use production environment credentials. It's so enabling. You notice that every one of these things is not about upgrade to technology A, B, or C, or change your system from this web framework to this framework or this language or that language. This is with your existing system as it is. These are enabling methods that will allow you to make the changes and the transitions that you'd like. Okay, so I did want to touch on a well-known word called Scrum, because it is so pervasive out there, and some of you may be doing Scrum or using some other agile methods or techniques. And I wanted to talk about how the Scrum basics and the DevOps basics go very well together, because in Scrum and every agile methodology that has iterative development, you want to produce a unit of working software every iteration or every sprint. And putting in place a basic DevOps pipeline gives you some technical methods that enable you to do that and work in smaller batch sizes. It enables deployments. It enables you to make changes to remove technical debt. It enables you to make architectural shifts and any other change that you want. And so if you've tried to implement Scrum or another agile method in order to solve some of these problems, but you still wonder why you can't make deadlines or set up estimates that have a chance to get met, putting in place these DevOps methods is the technical enablement of the Scrum process framework. And so I wanted to touch on that in case some people in the audience are planning on or have implemented Scrum or another agile methodology. So what's the alternative? We recommend for all your legacy systems putting in just the bare bone basics of a DevOps pipeline. You can add test code coverage later. You can add static code analysis later. You can add additional automated testing, or your first automated testing libraries later, but just the basics. Get those in place. Well, the alternative is you have to find a different way to build, and manual build processing, error prone, takes a long time. You're in your current situation. The alternative is you have your existing ability to deploy, your existing ability to set up new environments, and the ability to test. And so probably a lot of you have experienced, if it's not your current system, you've experienced systems where it's the epitome of Fred Brooks's tar pit essay. And many of you are probably familiar with Fred Brooks's book called The Mythical Man Month. Well, the book, The Mythical Man Month, is actually composed of a number of essays, and The Mythical Man Month is one essay. Another essay is called The Tar Pit. And Fred Brooks worked on software going back to 1959 and revised this book just after the turn of the century. And it seems that all of the same forces are at play, regardless of what libraries, frameworks, and tools and languages are used in these software systems. If you don't have the fundamentals of a frictionless development process end to end across your department from source code all the way to production and knowing what's happening in production and everything in between, if you don't have that, then it's like wading through your source code as if it's a tar pit. You try to make traction, you try to make progress, but it's just holding you back. It's tugging at your legs, and you can't seem to get everything done. You apply more and more effort, but you're not going anywhere. And you can't set or meet any dates or deadlines. And you want to improve the current situation. You want to improve the current system, but you can't get past this current status quo. And so really just in the last 8 years, these new modern methods for setting up an end-to-end development environment have emerged in the industry and have become accessible. And that's what is meant by setting up a very basic DevOps pipeline. The steps, the assembly line, essentially the process from source control to build to packaging to automatic validations in a deployed test environment, to deploying to a human test environment, to promoting to production, including everything, including automated database migrations, every component, nothing is manual, and automated self-checks. Those are the basics. You could add on top of that, but those are the basics. So how can we help as ClearMeasure? Well, call us. There's our phone number, 298-1232, area code 512. You can email us as well. Our job is to make your development team successful. You may call us, say, hey, look, can you directly modernize the system? Well, yes, we can help you do that, but you've got your own development team, and our vision, our joy is to see them productive and producing the software that helps your company achieve its business objectives. And so we can come in, we can assess your current software system, the processes you have in place, what methods you're using, and we can help you implement this most basic of foundational modern practice. And so we invite you to ask us to jumpstart your journey, and you can put in whatever questions either now in the Q&A window or after the fact. Email us any questions. Even if your department has spent every bit of budget you have for this year, just call and ask questions anyway. We're happy to help. We're happy to help you make your software better. And our joy is to see your development team just going so fast because we've helped you enable them with the modern practices so that your existing system that might have been written quite a while ago can just go at the speed of business instead of being a tar pit. So if now, along with following up, if anyone would like us to, and then we got a number of people on this webinar, if any of you would like us to follow up with you on this particular topic, then just go ahead and put a quick question in. Just say yes, please, so we can follow up, and that'll be great. So and you can type in additional questions at this point as well. And okay, Ben, got it. Yep, we'll follow up. Thank you. Sharon, I see it. Thanks. Jaya, yep, I see you. Awesome. Okay, so if there's any questions, you can put them in now. We'll make sure that any follow-up questions after the webinar are also included in direct follow-up afterwards. And we really thank you for taking the time to join us for this webinar. Don't forget, very, very soon, the announcement is going to go out for an advanced Q&A on automated deployments with Octopus Deploy, with a panel of myself and Paul Stovall, the founder and CEO of Octopus Deploy. So look at our ClearMeasure Twitter feed or sign up for our newsletter on our website and look for that announcement. It'll be going out very soon. That'll be our next webinar. We're really excited to see that, and appreciate the attendance, and hope you all have a great day.